The Slate Tablet Company produces a variety of electronic tablets. It wants to gather information on consumers' interest in its tablets. In each of the following cases, comment giving reasons whether or not the proposed sampling method introduces bias. A Slate Tablet Company representative stood outside an electronics store on a Saturday morning and asked people entering the store, if you were to purchase an electronic tablet, would you choose a Slate tablet or an inferior brand? So, for this one, specific time and location. That is a problem. It introduces bias because any time that you restrict the location or restrict the time, that is a problem. You're only going to get a certain section of the population. Also, the question is leading. That's the whole point about the inferior brand. 1,500 randomly selected mobile phone numbers were telephoned, and people were asked, which brand of electronic tablet do you prefer? So, the question is not leading. It's very neutral. But only mobile phone users, which I realise is nearly everybody, but only mobile phone users were in the sample. Not only that, those that would actually pick up for a number they don't recognise. So it could introduce bias as well. A common problem with a particular tablet is screen failure. The manufacturer of Slate tablets has found that 1% of its tablet screens will fail within 3 years. A sample of 200 tablets is taken. Let the random variable x denote the number of tablets that have a screen failure within 3 years in the sample of 200. What is the distribution of x? Well, we have a fixed number of trials and a constant probability of success, which suggests binomial. There would be 200 trials and it was 1%, so probability 0.01. What is the probability that more than 4 tablets will have a screen failure within 3 years? So that's more than 4. So we're after the probability of x being greater than 4. And that is the same as being greater than or equal to 5. And we can do this using the calculator. It's just going to be a binomial CDF, so discrete binomial CDF, with a lower of 5, an upper of 200, with 200 trials, probability of success 0.01, and we get 0.0517. In a random sample of 200 Slate tablets, 4 of them had a screen failure within 3 years. Calculate an approximate 95% confidence interval for the proportion of tablets that have screen failure within 3 years. Give your answer to 4 decimal places. Okay, so your P is going to be 4 out of 200, which is 0.02. Z95, which we can get from the calculator. Let's just quickly do that. I'm not always going to do that for this type of thing. But the E activities, Z score for CI, this is actually already on 0.95. And you can see the value there is 1.955. So I can't quite read that, 1.95996. 1.95996. And so what we would do is have our 0.02 take away 1.95996 times the square root of 0.02 times 0.98, which is just 1 take away 0.02, divided by the 200 for the sample, and then you have the 0.02 add that same thing. Although we don't need to actually calculate that because we've got this E activity here which says confidence interval for proportion, and we can just go up here and say that it was 4 out of 200, and 0.95 is already in there, and execute on that, and we'll get 0.0006 and 0.0394, and that does it. The company's quality control department wants the proportion of tablets with 40 screens to be between 0.5% and 1%. Based on your confidence interval, decide whether the quality control department is meeting its target. Justify your decision. The lower end is below the confidence interval, which is great because that means we've got less. But the upper end is above 0.01. We can see that just there. So upper target is not met.